Start recording. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We are, well, it's New Year's, actually. It is New Year's Day. No, New Year's Eve Day, the day before the year changes, however you properly say that. And so I thought we would spend the day taking a look at some stuff here in the issues drawer, because I feel like for 2017 we'll start with 3D stuff probably, I'm guessing. So we have some stuff to do. I figured I'd try some of these, and then we also have the fact that our room detection stuff wasn't quite done yet. We had just implemented it. We didn't have a chance to debug it last time. So that's something we got to do too. So we have plenty of stuff to do here to try and finish 2016 with everything tidied up. Some of them are easier than others. For example, entering being misspelled in the timer app certainly seems like something that's easy to fix, so we might as well just go ahead and do it. So let's jump in there. Today is day 355. Please use day 354's source code if you are trying to follow along at home. So let's take a look here at the timer stuff. I think that should be pretty straightforward, to say the least. So entering, there it is. I think all we need to do there is make sure that it only has that once. Looks like that was the only place for it. So hopefully that is sufficient for that. And off we go. So if I come over here to the timer, well, I'll have to recompile it when we're done. So I'm going to leave that here. I'm just going to say we fixed the string. I will have to recompile it once we stop the stream. Obviously, I can't recompile it now because we're in the middle of actually running it. I mean, I could recompile it, but I couldn't actually switch to it. So I'll need to switch to it at that point. All right, so let's take a look here. We've got a couple of different things. Let's take the easier one still first. As Abner was pointing out, and I think I fixed this basically everywhere else already. I went through all of the places on the website, in the tweet bot, and so on, that used to post old links to before Handmade Network started up and provided a place for the forums and the episode guide and stuff like this. But inside Handmade Hero, there was still like a readme.txt sort of a thing that's there for like people who are coming to it the first time, which is this guy right here. And so these are still using that sort of old style forums handmadehero.org bit. And so this day one link, we want to switch that over to like the place where the episode guide is now. So I'm going to jump over there and see what those links are. So I believe it's just asking about setting up the Windows build, right? It's that one. So I think we just want this is the correct one in terms of like how it works. Because this is day 001, so that should be correct. So I believe that link should be this link, right? And then let's take a look here and see if we've got forums. Yeah, we've got the forums here. Forums.handmadehero.org is no longer the correct place for the forums either. So we've got to change that to be here. Oops, didn't mean to open that. That way. So that's the correct link for the forums now, which is nice. That's a better link than that one, ugly one. So that should be that, I think. So let's see here if there's any more links. I don't think there are. It looks like that was all of them. So hopefully that updates those links properly, and now everything should be up to snuff, I think. OK. Looks good to me. So let's call that good. These should be fixed now. Close the comment. All right. So let's take a look at some of these other ones here, because we have a couple more. So obviously, like I said, this one we got to work on. This one here is an interesting one. It started because Abner was talking about trying to get Visual Studio 2015 to work out of the box, which, again, I have not installed Visual Studio 2015 because the cardinal rule of game development that unfortunately not many people follow, and sometimes they're forced not to follow it, which is unfortunate. But the best advice I could possibly give for game development, and I know that sounds weird, and it's not something I probably would have said 15 years ago, but based on the state of software today, cardinal rule of game development is you never upgrade anything during the development of the game. You will want to, because there'll be some feature that's supposedly in the next version of this thing, like Photoshop or Visual Studio or 3D Studio Max or Maya or Unity or whatever. You never, ever, ever upgrade anything in the middle of development. Why? Because you can guarantee that in that update they have introduced literally like thousands of new bugs that you will then have to work around, that break existing stuff you do, or that make it so you can't build your stuff anymore, or that change how things were working, and blah, 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 blah. So generally speaking, once you start a project, I usually say the tools are locked at that point. They don't change. And if for some reason you feel like you actually need to change tools, in my opinion, that's like a major decision. That's like a should we sell our company level decision. Everyone should get together and like hash it out for a day. And if everyone is not completely on board with it at the end of that, and like quite certain that it's an absolutely essential thing to do, you do not change tools. So that is why I have not upgraded to Visual Studio 2015 and never will until this project is done. But that said, if people are coming to this project and they have Visual Studio 2015 installed and they don't want to have to roll back to a previous version to get it to work, that doesn't mean we shouldn't go ahead and fix things in the code base that Visual Studio 2015 doesn't like to try and help those people out so they have a smoother experience. So I was asking these folks to tell me what the actual problems were. And Martin's sent in a really nice, in that Martin's way that he always does everything to the nth degree, sent in like a complete listing of all the things we need to do. So I felt like at that point it behooves us to actually follow them, because if someone's going through that level of trouble to give us that level of specificity, we should definitely go ahead and fix them. So let's start at the top. The first one is that in simple preprocessor, everywhere %.s is used, the length arguments need to have a type int, not size t. Spec requires a type for length. This can be fixed either in code or disabled with the WD warning. That seems like something we could fix in the code relatively well. We could just cast those to ints if we wanted to, among other things we could do. So let's just take a look at that and see inside simple preprocessor %.s, star.s. So you can see us looking at it here, right? So everywhere that we're doing that, I guess the problem is that text length here is defined as a size t. And so what we could do, since we really don't ever need it to not be a size t, we could probably make it so that that wasn't a size t, because we're never going to be processing 4 gigabytes of text. And a single token would never occupy that much space either. So we could, if we wanted to, just change that to be an integer for more efficacious printing. It feels a little wrong to take code that used to be capable of handling everything, though, and change it just for the printfs. So I'm not sure what the right thing to do is. At the same time, it seems kind of a little bit wrong here to kind of go ahead and cast everywhere. Yeah, I don't know. But I think that's probably, honestly, the right thing to do. I mean, because I really don't think like breaking the code functionality is the right thing to do. So I think this is probably what we would want to do. And let's see if that's all of them. 1, 2, 3, 4, 5. So there's a 6 here. Let's get that one. And that one we'll just do as a prophylaxis in case anyone wants to put it in there. So, all right, I think we've got that one. In Handmade intrinsics, absolute values should use fabs because fabs are trivial. That's true. I didn't know we were still calling that. Let's go take a look at that, and I'll talk a little bit about that in a second here. I must have been yeah, OK. So this is sort of a mistake that I guess I just did inadvertently because I didn't do it here. And just to give you a little bit of background here, what's going on here is that in the C runtime library, which we don't really use much of, so I haven't had any occasion to really talk about it, and I've often said multiple times at the end we'll probably replace it with our own library as well. So that's double reason not to talk about it. But just so that you're aware of it, because sometimes you will decide to program using the C runtime library, in which case it's good to know. Their math routines oftentimes have two different versions. They have one version that takes a double and returns a double, and that's the kind that doesn't have an F on the end. So that would take a double and return a double. And then a version that does have an F on the end, and that takes a float and returns a float. And so if you take a look at what we were doing here with fabs, we were going to be passing fabs a double. We were going to be passing fabs a float, and since fabs is spec'd as taking a double, it would have upconverted that to a double. No harm there. But then it would return us a double, and since we were stuffing that into a regular float, a 32-bit float, that would trigger a compiler warning that says, hey, I'm like down converting this value. Like I'm taking a value that was 64 bits turning into one that's 32 bits. Are you sure you want to lose that precision? And so that's all that's happening there. So if we change that, that's just a typo. There's no reason we wanted to call the regular fabs. So that's just should be fixed regardless, because there's no reason to call the double version of fabs. It's not really going to matter because it's a single absolute value, but you know that in general we don't want to call 64-bit absolute value anyway if we don't need to, because you know, maybe the compiler can do something faster by doing 4 of them at a time. Who knows what it could do? But point being, letting it know that we're not trying to do that is important anyway. In the future, we'll be changing that to an intrinsic probably, and so on. Anyway, align POW2 macro complains about 0 extending a 32-bit value to memory index for the size, changes it to this, fixes the warning. Align POW2, let's take a look at where that is. Let's see, align POW2, actually, align POW2. Thank you, Alan, for the search. OK, here we go. And so let's see here. I'm just going to take a look at what he was saying and look at these two side by side. I see. So I'm assuming that the problem here is just deals with the size variance of these things, basically. So when we do align POW2, the problem here is that the alignment value could be anything, right? The value is the thing that we're trying to align. So typically that's like a pointer or a count. And if that count was 32 bits, we probably wouldn't have a problem, because the integral promotion in C, the way it works is things will generally end up as ints as they go. And so this thing would just all work out to an int. It would do this sub-expression over here. That would become an int. It would do this one. This would become an int. And you would AND two ints together, and everyone's happy, right? That's all good. But assuming that the thing we were trying to align was a pointer, then what can often happen is the pointer is going to be 64 bits, but the alignment value will probably just be an int of some kind, right? Like 4, right? Which by default, on this compiler, is, you know, because compilers are free to define int to be whatever they want int to be in terms of size, right? An int could be 16 bits, could be 32 bits. On this platform, an int is 32 bits. Integral promotion means that this expression will stay in int, right? So not alignment -1 will stay in int. And then over here, we'll get value plus alignment -1. That will become a 64-bit value. And it will do an AND of the 64-bit value with the 32-bit value. And I don't really know what will happen in terms of the fact that this is now a pointer. My guess is that since this is now a pointer, and you're trying to AND a pointer with a 32-bit non-pointer, I don't know. I'm just assuming that something bad happens here in terms of the compiler's guesses. I'm not super good with C++'s rules about what can and cannot be converted to what. So I can't say specifically what triggers the problem. But as you can see, what Martin said fixed it on 2015 is just telling this expression to convert to 64 bits first before we did anything with it. And so I will take his word for that that works, and off we go, right? And again, this UMM is specified to be an integer the size of memory, an unsigned integer the size of memory. And so even in 32-bit mode, that would still be OK. It's not going to try and convert it to 64-bit in 32-bit mode. So this will just make sure it stays the size of a pointer, which is probably what we want. Although that said, I guess I don't really know if that's true either. The reason that I don't know if that's true is because if you imagine what would happen if we were trying to align the 32-bit value, is this would automatically turn it into a 64-bit value on 64-bit architectures, right? Because what will happen here is this will become 32-bit, this will become 64-bit, and if this was still a 32-bit value, whatever it was, the whole thing would get converted to 64 bits for no reason. So that's a little bit of a problem. I want to read this again. Align POW2 macro complains about 0 extending a U32 value for the tilde operator to memory index of greater size. Yeah. So that's exactly what that is, right? It's trying to. So I guess it's just because when it's going to do this not, it doesn't like the fact that it has to figure out how long it has to be, I guess. I'm not sure exactly what the problem is there. So I'm not sure how to write this in a way. I'm trying to think of how to write this in a way that it ends up being the correct size here. I mean, one way to do it might be to just have a dummy thing in there that forces the size to be correct. I don't know. I'm trying to think. Like, for example, could you do something ridiculous like that? Where you're basically taking something that's a non-value, like a 0, and you're inserting it into the term so that it knows that this, however big this was, it will have to upconvert this to that same bit size. So I don't know about that one, Martins. I'm gonna say let's assume that that's a good idea. When I say good idea, I don't really mean good. I mean in that way that I hate the fact that I in C have to even think about things like that, because there should be ways of just telling the compiler what you wanted to do instead of having to come at it sideways. But yeah, so let's just put that in there for now, and then I'll talk to Martin separately when he takes a look at this, and he'll let me know if that fixes the problem in a way that's going to work. I'm just kind of like trying to figure out how to get the compiler to do something reasonable there that will work in all cases. So let's see. Debug pick entity function, it doesn't like this cast. It wants it this way. Cast to the UMM first. OK, that's fine. So let's take a look at debug pick entity. Let's see. Oh, it's debug pointer ID. Sorry, I was looking at the wrong thing. So it is this. Debug pointer ID. So this is just one of those pointer cast things where I'm upconverting something to a pointer, and it wants me to first convert it to 64 bits, then convert it to a pointer on 64-bit architectures. Kind of a useless thing, but OK. In Win32 Handmade CBP, this should be changed to this. OK, so the global back buffer width and height just have to be casted to U32s first. So let's take a look at that. That's an easy enough cast to add. There we go. And let's see. A lot of warning, declaration of XYZ hides function parameter, or declaration of XYZ hides previous local declaration. They could be potential bugs because if you try to use XYZ variable somewhere below, and we'll think that you're using one, but probably pick the second. Temporary fix would be blah. Here's a full list of locations where it happens. So since we have the full list of locations, we might as well go check them out and verify that they're OK. And that nothing weird has to happen there. I wish I could change. I don't know how to make this buffer editable. It would be cool if I could make it editable, because if I could make it editable, then I could jump to these directly. But oh well. Although maybe not, because I guess they don't have the source location in them. But anyway, so I'm going to go ahead and go to the scratch buffer here, put this in here, and then we can take a look at where these guys are. So let's go to 194 and take a look. A declaration of count hides the function parameter. That's true. So we can just name this something else, I suppose. Let's see where count is used here. So I think what I'd like to do here is maybe call this like the entry count, for example, just to make it clear what we're looking at here. I think that's just a better idea. And that way, that local count can still just say count, because otherwise, inside here, you might accidentally refer to count differently. So I think that's a better choice there. Oops. Let's see, declaration P, render group. Let's see. Yeah, we've got the P value here that's being passed to this, and I don't know what we want to call this exactly. We can call this a modified P or something like that. There we go. And then here, the P value that we actually pass down, we'll call that. So that's a totally reasonable thing. Let's take a look at asset. So in 270, asset index hides a function parameter. Let's see. So asset index is getting passed down here. And then we've got another asset index in here. So that does also seem confusing. Let's take a look at where that's actually being used. So really the only place that that's getting used is down at the bottom. So I feel like what we want to do there is maybe call that the new asset index. So when we do acquire asset memory, we just kind of do that on it, right? Let's just make sure that we're not violating anything there. OK. All right, so I think we've done all of these. Might as well just get rid of them. And now let's take a look at where we are on these asset ones. So we have asset. It looks like asset is getting used more than once, I guess. But I'm not sure. Yeah, so you can see we're just kind of dereferencing asset here for convenience. And I'm not sure. I'm not sure that we really need that second declaration. It seems like it's just that. And since the header asset index, this is inside a lock, so I'm not really sure what this is doing, because asset equals assets plus header asset index, right? And then we look to see if that's all good, and we don't change anything here. And then we immediately go grab that asset index out of the header asset index and then do the offset again, but we've already got it up here. So it kind of seems like that's just unnecessary, right? It seems like that's just that. And I think that was probably just one of those like stream sort of nonsense typo situations. Doesn't really make any sense. So I'm just going to go ahead and say that. Now our line numbers will be off a little bit here because we just edited them a little bit. but presumably we'll be able to figure it out. OK, so you can see again. So this is exactly the same situation here, right? We're changing the state on this asset, and then for some reason we're grabbing it again. Like we've already got it, and the ID value is not going to be changing here, right? Because the ID value is a local thing. So we don't need to re-get this asset. It's just it's the same asset, so it doesn't need to be accessed that way, as far as I know. And same again is true here. So I don't think those are actually relevant. So a lot of those are just redundant lookups. They were the exact same value. And let me just make sure that is that the last one. Yeah. As far as I can tell, those are all non things. All right, let's verify that that's still working properly, that I haven't broken anything. Looks like I haven't. And now let's take a look again at what's going on with some of these other ones. So handmade.cpp, if we go to 282, data block hides previous local declaration of data block. So that was kind of by design, is the only problem. That's a macro problem. So I'm not sure there's a whole lot we're really going to be able to do about that. For the time being, I guess what we can do is not nest them. The other thing we could do is just lean on the debug system, right? We could do this. We could do it this way. But the only other option would be to go change the macro to actually have like an auto-generated name that uses counter or something to avoid conflicting. But for now, I guess that's just the easiest way to do it. To do Casey had to move this out into its own block to avoid MSVC 2015 warning. Probably should eventually fix the macros to generate unique names to avoid enclosed blocks complaining of reused debug block. All right. Oops, I don't need to go back there. I've got it in the scratch buffer. OK. So hopefully that'll fix that problem. But I don't know. Again, someone with MSVC 2015 will have to test it. If we jump over here to debug UI, it says that info is redeclared. So apparently there's something else called info here. Yes, it's the font info. So let's take a look at where these things are used in general. You can see those infos being used in multiple places. So I think I'll just call this bitmap info. And we'll leave it at that. Let's see, we've got debug.cpp at 762. And let's see, text buffer. So the text buffer previously was this thing, and then we had the tooltip version. So maybe I'll just call this the tooltip buffer. Seems like a reasonable idea. And let's see. We have the handmade sort. Decorative count hides function parameter. Oh, that was just because it got included again. So we've already fixed that one. OpenGL. Declaration of previous. Oh, you're right, it does. So let's see. So I think probably all I would really want to do there is, since at is not used again, I think I would probably just wrap this up. In fact, I think I could do this if I was so inclined. Right? So basically just put that inside the loop so that now it's got kind of a natural enclosure, since that at is not used outside. And that keeps it more symmetric with the way these are written anyway. So that seems good. And we got a lot of things called entry. So we must have used entry up here. Ah, I see. So that's probably the wrong thing. So this is actually like the offset, right? This is actually entry offset. So let's see. Is there anywhere else that that's used? I don't think so. Nope. So that's all good. So all of those should be fine. And then we're kind of almost done here, which is nice. Let's see, we've got X and Y, but those are stepped over here. So let's see, X and Y. Those X's and Y's are used in a bunch of places. So I'm kind of interested to know what would happen if I was to do like step X and step Y, or something like that. All right, so that's here and here, and here and here. Oops. That seems reasonable. And while I'm at it, just for completeness in here, I feel like since these are texture X's, you know, maybe I'd call this something like that. Just to make it clearer what it actually was. That way we don't have X's and Y's floating around when really there's multiple X's and Y's in that sense. Seems reasonable. All right. So I think that would be OK. Let's take a look at where's 482. Oops. So I think I fixed both of those. I'm not sure, though. We'll have to get a check again from somebody else. So let's take a look at that one, 1520. And this is the exact same thing. So this is just, I'm going to switch it the same way I switched the other one to be entry offset. It just is just the loop in the regular renderer instead of the OpenGL renderer. And that should fix all of these. And then we're down to our very last one. There we go, 1209. So bytes rate just gets declared again for no apparent reason other than probably cut and paste. We don't care about that. We're never using it anyway. So off we go. All right. So I think that's all of them that I can think of that were listed there anyway. So let's go ahead and take a look at this. I think we've got all of these. Let's say, OK, Martins. I think we've changed all these. If you want to test it again and reopen this issue with new bugs, if there are any, I guess I should say MSVC 2015 incompatibilities. Wow, spelling. Please. That was some great spelling there. All right. So hopefully that will all be done. I guess I should say change all these in day 355. There we go. So hopefully that's all good. I don't know if it is or not, because someone with MSVC 2015 will have to test it first and let us know if we actually fixed them or if we broke them. So now we're down to just a few last things. Like I said, this one we fixed, but we just have to actually recompile and test it. The software renderer, the mouse move, and the GL scissors are the only ones we have left. Clang compatibility, if I am not mistaken, we're down to just this. This is the only thing that we have. And let me just double check. Because I feel like no one's ever sent in how we would fix it for Clang. And I don't build on Clang currently because we're only on Windows at the moment. So, yeah. OK. So taking a look at that, yeah, I think we're, is there a way to mark this as like waiting? Like, how does this work here? There we go. So that way we kind of know that this one is waiting for somebody to tell us what who's on Clang, who wants to figure it out. They can do that. These are enhancements. These are just feature requests. So now we're just down to these four. In this one, we are waiting on finishing the stream. So we're really just down to these three. OK, so let's start with this one because it's kind of an interesting one that I hadn't really thought about since we don't do mouse moves processing in this game. But basically what this is about is it's sort of a performance concern. I don't know that we can actually demonstrate the performance concern at all. It's not something that probably would ever cause a problem. But I felt like it was worth mentioning on the stream because it is kind of an interesting esoteric property of Windows that it seems like we would want to talk about so people are at least aware of it. So it seemed like a good opportunity to do so. So if we take a look in Win32 handmade.cpp, we can see inside there's a, let's see here, there it is. If you kind of cast your mind back to when we were originally doing the Win32 code, you can remember that we sort of had this notion that we need to occasionally pull Windows to see what events it has put in our message queue. And of course, Windows is kind of a nightmare as far as message queues are concerned. It's real bad. Basically, if you think about how one might want an operating system architected from the standpoint of a message queue, it makes a fair bit of sense, right? I have an application. The application needs to be able to process things that the operating system is notifying me about, but the operating system doesn't know how long it takes me to respond to them, when I want to respond to them, how to respond to them. So message queues make a fair bit of sense. A message queue is basically a thing that substitutes effectively for something like a callback or a function call that the operating system might want to make. But instead of the operating system having to make it right away, it can instead just shove it into this queue. And that way, the application, as it's running, can field the things from the queue when it can. And if it gets something from the queue that it can't field right away, it could always like process it a little bit later or do whatever. It's very flexible and nice. So message queues are actually a pretty nice thing. they make a lot of sense in intercode design, right? And so you can just, again, you can just think of it as any time you would have directly called a function or something, instead you just make messages that encapsulate what the function call was, and then the other person on the other side receives it. Why do you do this? Again, because if you're trying to write two things that are completely separate and you don't know anything about either of them, it makes sense to allow them to be processed in a more asynchronous way than having some kind of a direct binding. You could have done direct binding like with DLL linkage and stuff. It could have been the operating system just calls you directly, but queues are a lot more flexible, and so you can see why you might want that sort of a thing to be the way that inter-process communication is happening, rather, again, than direct function calls. Although direct function calls also happen as well, right? So that's the nice part about it. The bad part about it is that the way that Windows ended up going about this was in a very haphazard fashion, and this is probably because Windows is a architecture that's never really had sort of a high-level architect, looking at it and trying to force it towards a well-working system. There's definitely been times like when the Cutler folks and stuff came and did the first version of Windows NT, where there were people who kind of like tried to do some good stuff with it. It's not that there haven't been people who knew what they were doing, touched it at some point, but most of the people who have added stuff or made modifications to the Win32 API weren't really system architecture kinds of people who really thought these kind of things through very much. And mostly the way that things tend to get added, as far as I could tell, was in a very haphazard fashion with no real sort of overarching philosophy behind it, and not a lot of testing and not a lot of end user sort of clarity. It's just kind of like a big old mess in there. So as a result, the Windows message queue doesn't really operate anything like an actual message queue. So all of the good things that you might have wanted from the fact that there does appear to be this message queue in Windows, they're actually all not there. So it just ends up being a pain in the butt. For example, not all messages in the message queue will actually go through the message queue. Some of them short circuit and try to call their handler directly. So right there, the whole point of the asynchronous queuing behavior is out the window. It's no longer there. Windows actually just calls you directly back at like your window process or things like that, your window procedure and stuff, instead of going through the queue like it's supposed to. So this nice concept of a queue, out the window already. Second thing, it's threaded wrong. The message queue in Windows can only be processed by the thread that created that message queue in the first place. And so you end up not having one of the central reasons for having a queue in an operating system, which is to allow multiple threads to process things coming in on the queue in a sane way. That is out the window as well, because only one thread can ever look at the messages in the queue. So that's out the window. And then finally, the thing that's also out the window, like basically if you took everything that there was about a queue and you threw them out one by one, Windows actually has done that. So the last thing that we have in a queue is the concept that things go into the queue. But that's not actually what happens in Windows. So what happens in Windows instead is that sometimes things that go into the queue actually go into the queue. But other times, things that look like they should be going into the queue actually don't go into the queue. Instead, they get generated spontaneously by the act of looking at the queue. It's sort of like a quantum queue, if you will. And so what happens here is when you call peak message, right? Peak message as a call is saying, hey, go look at the queue and give me back a message if there is one. If there isn't one, just give me back nothing so that I know that there wasn't one, right? This makes a lot of sense for games because in games, what we want to do is process all the messages that are in the Windows queue. But once we've processed all the messages, we don't want to like sit there and wait for more messages because we've got rendering to go do, we've got sound to go do, we've got stuff to do. So we only want to get the messages that are actually in our queue. And it looks like, from a far enough away perspective, that that's what's happening, right? We call this peak message function, and we get back the things to the queue, and then eventually we stop getting things back, and we figure we've processed all the things from that Windows has to give us. But that's not what's actually going on under the hood. Under the hood, what's going on is that peak message will do that at first. So the first few things it will do when we call it is getting us the message from the Windows message queue and giving it back to us, right? So it's taking thing off of queue, giving it back to us, taking it off of queue, giving it back to us. But eventually it will run out of things to give it back to us. And at that point, in our mental model, what we think is happening is that got message will return false at that point, right? This will become false. So peak message will, our got message, peak message will return false, and we'll go, okay, it's out of messages. But that's not what it actually does internally. Instead, what it does internally is goes, oh, there's nothing left in the queue, but I got a call to peak message. So let me look and see if there are any messages of a type that I could generate right now to fill this queue so that it has something to get back, right? And those messages that fall into that category, and I don't know what all of them are offhand, I'll have to see if there's a list, but WM Paint and WM Mouse Move are two of them. So if your window could be repainted, or if the mouse had moved at all, in between the time when you last got a mouse move message and now, peak message will spontaneously generate those right now, right at this point. Does that make sense? So, as you might imagine, in a theoretical scenario, and I don't know if this is actually fully theoretically possible because I've never actually tried to get it to actually happen, and I'm not sure. You would have to probably write your own mouse driver to make it happen. I don't know, and it might not really be possible. I couldn't tell you. But in theory, I believe you might be able to get yourself into a situation where mouse move and paint messages were coming in so quickly and you were processing them slowly enough that you just stayed in this loop forever, right? Like, I don't really know if that's possible, but just the vague kind of idea of it is sort of possible, right? Like, meaning because Windows can generate WM Paint and WM Mouse Move messages in response to the movement of the mouse and the painting all the time, right? As often as it wants to, whenever there's no messages in the queue, in theory, every time we called peak message, it could just return a mouse move forever, right? So the question becomes, is there some way that we can structure this a little more carefully so that we don't have that happen, right? Now, adding insult to injury is the fact that if you look, we never use WM Mouse Move. Similarly, we never use WM Paint, right? Like, all we have is like a dummy handler for it. We don't care about those at all. We do our own mouse polling, and we do our own paint. So really, we just don't care about these. We literally do not care that they're happening at all. And so one thing we could do is in our peak message. One of the things that peak message allows us to do is pigeonhole what functions we actually care about getting. And so if you take a look at peak message, there we go. You can see that it allows us to specify a range where we can say what the minimum and maximum messages that we might want to get, right? And so what we could do here is we could just say, hey, let's skip the ones that we don't actually want, right? And so you could imagine something like this. Where in place of these, we said, OK, filter min, filter max, right? Which are these two here. This is the window handle, which we don't care about because we're getting messages from any window. We could say from 0 to WM whatever minus 1. So whatever this first one is, whether it's paint or mouse move, right? And then we could say from that one to the last one, right? And I don't know if we can pass a 0 for that one. Let me see here. I don't know if we can pass a 0, so we may have to do like the maximum possible message value. So we could just do, right, something like that. And we'll see. So what I want to do here is I just want to figure out, and I don't know if you remember this trick that I did before. I have this dummy Win32 project we created. That's a nice way to quickly search the documentation so we don't have to do it ourselves. If I want to, I could just say, oh, I know that WM mouse move and WM paint are the two things that I really don't want you to be doing. I don't care about them, so stop it, right? What I can do is go and see what they are. So WM mouse move is OX200, right? And then if I go back to here, WM paint is OXF. So paint clearly comes first. So what I could do is say, hey, give me everything up to WM paint. And then here, I want you to do, just skip over it and go to the rest of them, right? That would skip over paint. And then, again, I probably have to do one more here, because then I want to skip over one more. I would say, all right, WM mouse move -1. WM mouse move +1. And now we've basically notched out just those values, right? So we're basically saying, like, OK, we're skipping WM paint because we're going right up to it. And then we're skipping it and going right one after it. And then we're going right up to mouse move, skipping it, and going one after it, right? And so this would be, oops, got to switch back to my old project. So this would be what that looks like, right? And now we're not processing those messages. So now, our game is running, and we're never getting a mouse move or a WM paint, which is sort of just saying, like, hey, I don't care to ever receive these. We don't need to process these, so I'm never going to actually look at them. And so that's an interesting idea. Like I said, I don't really know how necessary that is, because I don't know that we could ever really get in a situation where that was causing us any real problems. But it's kind of worth noting. It's kind of worth noting. And today is day 355. Yeah, there we go. So again, not really sure that this matters particularly much, but yeah. And we'll let people test that a little bit to see whether that causes any additional problems, but hopefully that should be right. So we're basically just looking and said, OK, we're going to do got message. We're going to look to see if anything up to WM paint comes in. If nothing came in, then we'll try again to get something from paint to mouse move. If that didn't come in either, then we'll try one more time. Right? That's it. OK, so we're getting down to it here. Let's see. And so we've got this done. So we've got these two left to do. Let's take a look at push clip rect and GL scissor. I think I know what's being talked about here, but I don't quite remember the exact thing. So let me just reread it again. The bounds for push clip rect are in world coordinates, and these are passed directly to GL scissor. These should be converted to screen space first. The effect of this bug can be seen in the debug profile if running the game at a lower resolution. OK, so this is just a case of us not actually translating our push clip rect coordinates first. to the screen resolution. So since Kim's saying that we could reproduce this bug easily by switching to a lower resolution, let's go ahead and switch to a lower resolution, because the best way to fix something is if you can see it break, right? And right now we can't see it break, so we could try to fix this, but we wouldn't really know if we fixed it properly. So I'm going to go ahead and comment that out and see if I can observe the bug in practice, and that way we'll fix it. So right off the bat, we're in bad shape, right? Because that's clipped wrong to begin with. So let's see if that is in fact clipping or related or not, because I guess we don't really technically know that it is. In fact, I'm kind of curious. That actually looks like it's not scaling the screen in the first place. This looks like we might have bugs other than that in here, honestly. And also, I don't know why we're still calling this Win32 resize div section, since yeah, since that's not exactly what it does exclusively now. But anyway, point being, let's try and fix all that. All right. I don't really like this thing I'm eating, I'll be honest with you. I really like pound cake. Like those dense, butter cake sorts of things. But for some reason, they always put like lemon in them. They're always lemon pound cake. And I don't like lemon flavor like that. I mean, I like lemons just fine. I just don't like them in dessert. So it's this weird thing of like you can't ever get a pound cake without the lemon in it anymore for some reason. And that's a lemon one. I don't know. Sometimes I'm just happy to have food. That's probably how it should be, right? I mean, if you can have food, you should be happy. And so I was kind of just happy to have a pound cake at all. And there you go. Anyway, human beings, especially in the developed world, probably don't have very much real appreciation for the incredible scarcity that food used to come at. I mean, it used to pretty much dictate everything that society did, was like how you were going to get food. And nowadays, there's whole portions of the globe somehow, Seattle obviously being one of them, where they just have food like everywhere. And you can still be in a situation that capitalism dictates that you don't get to have the food, which is a questionable practice to begin with, but the bottom line is that there is plenty of food. And that wasn't really the case even as recently as 100 years ago or so. Major developed nations were still not sure how they were going to feed their populaces. It's like it wasn't just a question of how do you feed everybody? It was a question of how do you feed people at all. And so, yeah, just kind of an interesting perspective. We're living at this sort of point in history where you can think of it as there are places on the globe which have an abundance of food, and that was not true, really. I mean, except in very small circumstances a long time ago, and so it's pretty weird. I don't know why I'm getting off on this tangent on food supplies and feeling lucky that you have food even in a developed nation, because it seems kind of ridiculous at this point. But it's true. That's all I can say. It's true. Even in a developed nation, even for places like Seattle or something, the concept that you could feed as many people as are in Seattle right now who are getting fed every day with all this food, is totally ridiculous. Like that's, it's a very strange time that we live in that sort of thing can happen at all. Anyway, moving on, we have to figure out how to deal with this scaling stuff here at the moment, and I just want to go in to figure out when we initialize OpenGL. One of the things that I don't really know at this point is how we're setting that up exactly. So it looks like we're passing in, when we do bind frame buffer. Well, you know what? Let me check one thing real quick first as well. I want to use the software render for a second here. So let's see, global software rendering. I want to see how much of this is an OpenGL problem and how much of this isn't. Let's take a look here. So here's our software renderer, and so you can see our software renderer is still working correctly. So it looks like this is largely a problem, I guess, with our hardware renderer. Yeah. So it looks like we want to fix that so that our hardware renderer is doing things correctly, because our software renderer does appear to be. So let's take a look at that for a second here and see why that's happening. So when we do clip rect pushing, we've got that. Let's see, that's down here in our render loop. Tree offset. Tree offset. So when we're pulling stuff off of our render queue here, well, we're not really pulling stuff off. As we're walking our render queue, we get into this circumstance where we take a look to see whether we need to push a clip rect, and if we do push the clip rect, right? And so you can see here, like the code on the GL side is a little more complicated, and the reason it's a little more complicated is because it needs to use those dynamic frame buffers, whereas of course in the software renderer we kind of have more control over that sort of stuff, so we don't have to worry about it as much. We don't have to prepare resources and junk like that. We just set a pointer and go. Wouldn't that be nice? Someday when we have programmable GPUs. Someday. Assuming that day ever comes. Anyway, so in here, when we're dealing with the OpenGL version, you can kind of see what's happening here. We've got the OpenGL bind frame buffer stuff, which is going to go ahead and do sort of the same thing we're doing here. Presumably the intersect operation still occurs. Does it still occur? We don't have a base clip rect, I guess, so we don't have to do that now that I think about it, because it's not chunk rendering yet. This is for the tiled rendering, and we don't have to do that here. So we're just looking at the GL scissor call, which is this part right here. Now, the GL scissor part, I guess, is essentially just happening with the clip rect bit here. So I'm curious to know why that one is working in this case. The other one isn't. This must be a separate bug. Let's see. Hold on a second. Let's see what happens with the debug system profile code. Of course, it creates something that's too big in the first place, so it's hard to see. Hold on one second. So yeah, if I was to do one, let's say that was like, can I do one that's bigger? I don't know if this will work. So it sure looks like this works properly. Because this is the only place I know of that's using the clip region in that way. It sure looks like that works properly at the moment. So I'm not sure if that's really the bug. It looks like maybe the bug is more just the fact that the yeah, it looks like the bug must be something slightly subtler, because in this case, we are still using the clip rect coordinates directly for clipping, in this case, where we just used that clip rect. And so presumably, if that works in the software renderer, we should be able to make it work in the GL renderer as well. And so I guess part of that problem may be just GL's interpretation of GL Scissor is not in in screen space. It's in viewport space, potentially. So we should take a look at that. I do remember there being something weird with GL Scissor in that way. So I'll have to think about that in a second. But first, let's take a look. So when we do our clip rect here, we do an offset of the clip rect when we're not using render targets, or the target is 0. We do an offset of the clip rect. So this is just to make sure we line ourselves up when we're just drawing the screen, to line ourselves up so that we're offsetted a little bit, and we do like a black bars kind of a thing, if we don't occupy the entire screen size. I think that's all that's doing, right? And I think, did we have a windowed mode at some point? I think we did. Let's take a look at that if we have a way to do that here. So if I change the size of this, right? You can see that that all still appears to work correctly, as far as I can tell. So now if I turn software rendering to false, so we're doing hardware rendering, hardware rendering, you can see now, does exhibit the bug. There you go. Now, for some reason, hardware rendering is not does not exhibit the problem of changing the screen resolution causing a problem. So basically, it's not, for whatever reason, doing our scaling this way does not pose a problem. Yet changing this from 1920 by 1080 does. So is that because we hard-coded that somewhere when we were doing the OpenGL stuff or something? I'm not sure why that would, why that was happening. So I think we've basically got two bugs here. One is we've got the scissor is not properly aligned, right? You can see that happening here very clearly, right? And then the other one is that if we don't start out at 1920 by 1080, we're getting this sort of other problem in only the hardware renderer. Again, both of these cases, it's only the hardware renderer. The software renderer just seems to work exactly, and off you go. Which, by the way, tends to be the case with software rendering. Software rendering is so nice because you control everything and it just tends to work. Anyway, but anyway, so let's take a look at how that goes. I think it's like anything else. If you wrote it, you understand how it all works, you're less likely to have weird things where you're like, oh, you know, this particular call, I forgot that it doesn't do that thing, or this, that, or the other thing. So anyway, let's take a look at why that's happening. So first things first. So the scissor being misaligned, I'm going to take a quick look at the documentation for GL Scissor just so we are correctly interpreting what those parameters are supposed to mean, like what space they're supposed to be in. Right. So here's a GL Scissor call, and we've got the width and the height, presumably, and the x and the y. You know, we're computing those correctly in some space, right? Because we're doing max minus min. So we are doing x, y, width, and height. We're definitely sending that down. But the question is, what's the space? And it says it defines a rectangle in window coordinates. OK. The first two arguments, x and y, specify the lower left corner of the box with access to the width of the box to enable the scissor test, blah, blah, blah. Right? So it says that those are specified in window coordinates. Right? So now let's take a look at GL viewport, which is the other call that we have that has to do with this situation. Oh, didn't somebody say docs.gl or something? There it is. So let's take a look at GL viewport. Here's GL viewport. So I assume that our problem here is that our GL viewport call, right? So when we do open GL bind frame buffer, oops. There we go. Sorry, it's that season where I'm very stuffy. OpenGL bind frame buffer, in this case, you can see that what we do here is we say, like, well, how big is this draw region supposed to be, right? And the draw region, again, is something that that sort of comes in up here, I believe, right? So here's the draw region. And you can kind of see that we're doing a couple different things here. The draw region is how big the entire thing is that we're supposed to draw to, right? And we're passing down to the, in the draw region, we're saying that our GL viewport is going to be whatever that size is, right? And you can see that we've got a couple different ways that we're doing that. So in the case where we're drawing to a frame buffer, we're just going to draw it aligned, right? But in the case where we're drawing to the final screen, we're going to use the min x and the min y for the viewport when we pass it down. And again, the reason that we're doing that is just because we're trying to, when we're drawing to the screen, we're trying to put it in the right place for the viewer to see it. Whereas when we're drawing to a texture, we're just going to use that texture in some other way, so we don't need to have it be aligned in that way. So here when we call our GL viewport call and we're passing the window width and the window height, I feel like that looks roughly correct to me. Like I don't see any reason why that would be unusual. Now, when we come in here, though, you can see what's happening, that the clip rect comes from a different place. So the window width and the window height, and then the clip rect itself has not actually been transformed in any way that is relative to the window width and window height, right? So really, I suppose that is where our problem lies. And this is probably what Kim was talking about when he said world coordinates, right? So the clip rect in this case, and the window width and the window height, the clip rect is going to be something specified in terms of that viewport, I suppose, but it's not going to be interpreted in terms of the viewport. Which of course means I'm not sure exactly how we want this to be interpreted. But so when we actually set this GL scissor, and we've got the min x and the min y here, I think we would first need to know, and let's take a quick look in here. So you can see here that when we do our transform, we've got this screen area bit. And when we're doing pixel widths and pixel heights, we're doing everything in terms of the screen area. And the screen area, when we set it, let's see if we can find it here. Our game render commands, let's see where our screen area actually is, because that comes from here, I would assume. It just comes from width and height, right, in game render commands. Let me just double check that all that's true. So whenever we call begin render group, that's where we pass the pixel width and the pixel height in here, right? And you can see that getting done right here, right? And it passes in the width and the height that it got from render command. So that is where that comes from. We could make this a lot cleaner if we wanted to. Probably some way we do want to. So it's taking the global back buffer width and the global back buffer height, and those are the things that are coming in as part of this, part of that screen area, right? So when we do a push clip rect, like we have in here, let's see, we've got it like for example, one of these things. When we do a push clip rect for one of these things, and we're setting it up, you can see that we just try to specify x, y, width, and height. And we don't really in any way transform those. Like if we were doing any of these guys, let me just double check here which ones we're doing. So in these cases, let's see, backing transform. So it looks like we are going through the object transform. It looks like we're going through this call, yes? So we do go through the full pipeline here, which means that when we transform these guys, they are getting transformed by whatever the basis is here. And scaled out and all those other good sorts of things, right? And then they're just getting recorded after that is done and placed in here. So when it goes through this transform, at that point, we would expect it to have been transformed out by however big the screen was, right? Because that piece of information gets taken into account during the entity basis P, right? You've got meters to pixels that comes in here. You've got the screen center, and so on. Now, I guess, though, at that point, it doesn't take into account. Yeah, so it does. They're in our concept of the screen coordinates at that point, but they're not. It's not in any way related to where the window actually is, because it's not being offset by anything in addition to that. Like it's not being offset by anything, which is why that additional offset has to be there in the OpenGL path, right? That's why this offset has to be there, right? So again, looking at this one though, there isn't anything special done to handle it in the case of the software renderer, which is weird, right? You would have expected it either to both have to do it or neither. So the fact that we're able to just use all of these, because it looks like, and it does look like the screen information, like how big the screen is sort of baked in to all the transforms that happen there. So when we take a look at the clip rect stuff here, it's a little confusing to me why we're sort of seeing that difference there. where we have to account for that. It's just a little puzzling, wouldn't you say? Because in theory, yeah, I just don't understand why that's a problem. Because in theory, these should be in the same coordinate space if they are working correctly inside the software renderer, which is really the bizarre part, right? And it's not obvious to me why you would have anything weirder happen there, because it should happen exactly the same way. And furthermore, I don't see why we're getting strange results when we set the size of the buffer differently in that case either, right? Yeah, I really just don't understand that. I'm very confused by that, to say the least. Because I can't figure out why we would have a disparity between those two things. And I feel like I should be able to figure that out, because if one of them has the problem and one of them doesn't, right, there should be a solid explanation for why that's the case, something that they're doing differently that would explain that fact, right? So, you know, there's the hardware renderer, there's the software renderer, and they both agree here. But when I go to look at the profile, for example, they won't agree, is the implication, right? So there's, right, hardware and software. You can see, again, totally incorrect there. And so you can see that the clip rect in this case sort of converges to the correct answer as well, as I guess you get bigger. Like if I do that, suddenly it's right. And again, this seems to have to do, it's just very, very strange. It seems to have to do with the difference between the size of the screen and the original size, the expected size, the 1920 by 1080, which again makes very, very little sense to me, right? And you can see that it's scaled wrong as well. So it definitely is a scaling problem, because you can see, I don't know if you can see this, but the motion of this line doesn't go linearly with the motion of this line. So the size of the clip rect is getting increased in a way that is not 1-to-1. It's like it's a factor of 2 or something, right? Well, it's probably a factor of however big the screen size is versus the total screen size. So again, I'm really not sure why that's happening. Yeah, that really doesn't make a lot of sense to me. Okay, so I think I'm just let's just dig in one more time here. Because again, these are both supposed to be in window coordinates, right? Because it says GL viewport specifies the affine transformation of x and y from normalized device coordinates to window coordinates and it's doing this. So they're both in the same space. So I guess what I would infer from this is that this transform, the GL viewport transform, is going to happen on everything that we put in except the GL scissor, right? And so I'm guessing that it must just be thinking that through, that that is the problem there. GL viewport, in this case, this transform right here is going to happen to our positions, but it's not going to happen to our GL scissor positions, right? And so I guess that is the primary problem that we're going to face. So let's take a look here with our GL scissor down here. And we can see what we're doing here. So we have like 0, 0, window width, window height. So all of our x and y's that come through here are going to be multiplied by half the width, right? And then have the offset added to them, right? So that's what's going to happen. And our GL scissor, like our clip rect, presumably is, I guess we're saying, is should be in that same space. Right, because everyone else is going to have to be. So that would imply that we would have to take normalized device coordinates, right, which is the clip rect value divided by whatever the window width actually is, right? Because we've got to normalize the coordinates first. And normalized device coordinates, right, is saying that we've turned the screen, the entire area we're drawing to, we've turned it into, 0 to 1 or -1 to 1. I think GL uses -1 to 1. And then we're going to multiply it. Well, you can tell right here in the equation it's -1 to 1. Because you can see it's multiplying by the width over 2. If it was 0 to 1, it would multiply by the width. If it's -1 to 1, it multiplies by the width over 2. And then the offset comes in there. So let's take a look, I guess, in Milton at this for a second. We should be able to work this out. Let's see, Milton. Where are you, Milton? There you are. OK, so what we know here is that the normalized device coordinates for this thing, so I'm just going to go ahead and copy this equation down. So essentially what we're saying is that the actual coordinates we're going to use is going to be the input coordinate plus 1 over w over 2, right, half the width, plus the center of the screen, right? At least I assume that, yeah, it's right. This plus the, oh wait, plus the lower left corner. Call that left. So yeah, so you can see what the plus 1 is here, right? Because this x of n is going to go from -1 to 1, right? And remember, let's just talk about what normalized device coordinates are here. We've talked about this before. So in OpenGL, it assumes a system where the center is 0, 0, right, in terms of normalized device coordinates. -1 to 1, right, goes horizontally, right? -1 to 1 goes vertically, like so on. And so the center lines are always 0, and the far ends are -1 or 1 in either case. Now, Another way to do normalized device coordinates would have been like, 0, 0 is here and 1, 1 is here. But that's not what we're doing in GL. GL uses -1 to 1, so each axis goes -1 to 1, right? So this would be -1, -1, and this is 1, 1, right? This is 0, 0. This is 1, oops, -1, and this is -1, 1. So the +1 is just to turn this into a 0 to 2, because it's coming in as -1 to 1, this value is, and we're trying to turn it into 0 to 2 so that we can multiply by the width over 2, cancel the 2's, and actually just get what would have essentially been a 0 to 1 mapping goes to a 0 to width mapping, right? That's what we're trying to do. And then when we do this plus x1 here, that's just to offset if the base corner of the window is not supposed to be in the lower left corner, then this is our offset there, right? So there's our equation that we're using to try and line this up. And so in this case, what we need to do is just figure out how to take care of this transform part and then do this offset, right? So let's take a look at how this is coming in. What we need to figure out is what are our normalized device coordinates for our clip rect, right? Well, our clip rect in this case, let's go back here. Our clip rect in this case is not based on the draw region, right? It's based on whatever that command's width and command's height are, right? So what we want to do is say our clip value, our clip coordinates that come in, what we want to do is normalize them first by making them be relative to that width, the width of whatever the basic render region is, right? So whatever that command width is, we want to first normalize them to that, because we know they're in this space. So we'd normalize them to that first. And then we would know that we would have them already ranging from 0 to 1, because we're not using -1 to 1 space here. We'd know that we were ranging in the correct space there. And then we want to multiply them to get them back to this width. This here is the draw region width. This is whatever we were using for the viewport, right? So that's that window width, window height situation here, right? So then we would do the width of the window. So what we really need here is we need this ratio. The reason that our normalized device coordinates are wrong in this case is because we're not using this ratio. We need the window width over the window. We need the window width over the command width, right? We essentially need excuse me. We need commands width over whatever the draw region width. We need to multiply by this to get that ratio to be correct, right? In order to transform our GL scissor the way that we think we should transform our GL scissor. And then we also need to handle the offset at that point, but we're already handling the offset in this clause right here, right? So I think the only thing that we really have to do here is we have to say, OK, our clip rect first has to be scaled by that scale value. So our clip rect min x times equals scale x and we know what this has to be because, again, we have our draw region width and our draw region height. So we know, just make sure we've got that up here somewhere. There we go. So we've got our draw region width and our draw region height here. And we want to do that scale. So again, to do this commands width to to ensure that our commands width is actually going to be valid, we need to make sure that it's non-zero because we're going to have to divide by it. So at some point here, we really should be testing that. I don't know if we test that anywhere else where we might need to do a divide. I don't know if we're actually doing any divides here. It looks like we're actually not, other than bitmap sizes, which we know to be correct. So I think what I'll have to do here is create some kind of a ratio, a safe ratio system. So what I'm going to do here is I'm going to say, all right, when this thing comes in and we have the command, we have this like command width and command height, I'm going to do like inv command width equals 1.0 over commands width, and inv command height equals 1.0 over commands height, because I'm going to have to divide by these. And what I want to do is we have, if you remember, we have our safe ratio. I want to be able to make it so that this will work no matter what. So I'm going to actually call safe ratio here. So in case commands width happens to be 0, I still want it to work. So my scale is going to be the width and the height of the draw region that we're specifying here. I want to use that scale, and then I want to say the width and height of the draw region, scaled by whatever that inverse command width and height are to get that ratio proper, right? So I think that would give us the correct values. Of course, that is if I actually typed that in right. To adjust for that transform that GL viewport's doing, I believe that would give us the correct values. Now, the only thing that I'm not certain about here is when we're calling this the draw region get width here, if we weren't using render targets, then we will not have called GL viewport. And so in that case, the draw region is just going to be the overall draw region. But I guess, does that draw region ever actually change? So that doesn't actually change. So it looks like these scale x, scale y values actually would never be different, right? They could be computed at the beginning. And just saved, I think. Right? So in theory, that's something that I could do right here. And then the safe ratio actually is just actually just of these values, right? We can actually dispense with this whole thing and just say like, oh, okay, whatever the draw region width and the draw region height are, knock yourself out, and those will just be what we use. Let's see, this needs to be an F32 as well. From F32 to int32. Oh, interesting. So the clip rect here is a 2i. So when we do this scale, we're going to have to do another rounding of it, I suppose, unfortunately. So we're actually going to have to do a round real 32 to int32 here. Because these have to be pixel values at the end. Okay. Wow, that was not a good edit job. Okay. Butterfingery. So yeah, so now we actually are doing that transform, and now we have to go make sure that we've actually got it correct. So that will transform the scale of those properly, and I think also do the offset properly. Of course, we don't actually know if that's true. So let's actually start to work this through now and see if we've gotten any better. So again, let's open up something that actually is using the clip-rect. So here are the clip-rects. Again, let's switch between the two, software rendering, hardware rendering. And so it looks like now we've got those scaled properly. So there we go. And we can sort of double check that that's true. Does appear to be true. Good. So now we've got that scale. And again, that's just remembering that the GL scissor is in window space, just like GL viewport is. And so GL viewport was applying a scale transform that we were not compensating for, and now we are. Now, the thing that I don't know is, did that fix our other problem? We can go back to software rendering being off by default. So now we've fixed that sort of window version here. Right? So that all looks good. But what happens with our switch? Oh, I accidentally destroyed my little half version here. Let's put that back. What happens if we say that we want the back buffer to be 960 by 540? How does that affect things now, right? So it looks like, thankfully, that was the same problem, just not applying that. So now we're in a situation where we can also count on that to work in the hardware render as well. All right, so scale bug resolved as far as we can tell. Today is day 55, right? Yeah. So taking a look here now, let's see, we've still got some time left, and it looks like we only have one bug left, which is the software renderer draw rectangle pointers clip mask. In draw rectangle, if the fill rect is less than 4 pixels wide, only the start clip mask will be used, ignoring the end clip mask leading to wide rectangles. If it's less than 4 pixels wide, start clip mask needs to be ANDed with the end clip mask pre-loop. That makes some sense. We don't use fill rect a whole heck of a lot. We never really tested it. We just kind of threw it in there. And so I feel like that's very likely to be wrong. In draw rectangle quickly, there shouldn't be a need for the clip masks. The fill rect still needs to be rounded up-down, as the UV01 comparison should make it redundant, I think. That's a very good point. That's a very, very good point. So I think both of those things are probably true. Let's take a look. So here's draw rectangle, and we're in the fast case here, which is this case. So there's the start and end clip masks. You can see them there. And we're just looking up which one of them we're going to do, right? We say, OK, let's go ahead and see whether we need to do either of them. We'll take the start clip mask. We'll take the end clip mask, and off we go. And then when we come in here, we start with the start clip mask, and we always use it. And then we only switch to the end clip mask at the end here. So yeah, if we have a wider rectangle, if we have a narrow rectangle, that wouldn't work. So yeah, I think what we want to do here is say, if we know that we're not going to fill enough pixels, we need to AND them together. Nice. And that's not particularly difficult, right? All we're talking about here is like start clip mask and the end clip mask. We're just talking about that, right? Where we AND these two together. And so the only question, because again, that'll make sure that it'll only use what's available in both the start and clip mask, so they're actually work together. But the problem here is we need some way to determine when that actually needs to happen, right? And the case where that needs to happen is if the fill rect max x minus the fill rect min x, right? If that is going to be less than or equal to 4, I believe, right? So if the total number of pixels that we're doing is 0, 1, 2, or 3, and I guess 4 wouldn't matter because the start would be full. So I guess it's really just 3, right? If the total number of pixels that we're going to be doing is less than or equal to 3, then we know that we're inside a single, the entire rectangle fits inside a single vertical column of 4 pixels. We need to make sure that we use both the start and end clip masks in that case. I believe that's the case. Now, I don't know that we're actually using any of those rectangles that would actually fall into this category, unfortunately. Yeah. I'm not sure we can really test this in any useful way. I suppose if I turned off some things, we could see what the size of that rectangle was when it was being drawn. Like right now, you can see that there's kind of a little weirdness to it. So I think that must be incorrect, although I don't know if that's just because of z-fighting, because we can't actually tell when we're still drawing stuff here. What if I turned off anything that wasn't push rect there? So we weren't getting any of those. What I could do is just say like, oh, OK, in render group, push rect. Let's see. Well, the problem is that push rect outline actually uses that. I suppose what I could do here is just do like this sort of thing. This is not going to be. I will do it a slightly different way. So I'm going to go into Entity. I'm just going to turn off places where I am drawing that. So that's in traversables. I'm just going to go ahead and say don't do that. So there we go. And now we should be able to test these a little bit better. So yeah, you can kind of see they're like definitely not correct. So let's take a look at that. So yeah, if the fill rect one thing I do want to do is I want to see if 0 here. Let me take this out. And let me take a look at config as well. I'm going to set this true. What was the 30-ish? Here we go. So that's just how that's working at the moment. So essentially what we need to do is make sure that we're actually doing this test correctly. because maybe we weren't. So let's see how that was working. So the fill rect. So this fill rect is not the rounded version, right? Somewhere we must round this up to 4 pixels at a time. Although I don't know where that actually is happening. So let's take a look at that. Let's see. Min x and min y. And we do plus equals 4. So I'm not sure where that's actually happening. Interesting. So I guess we never actually bother rounding this at all. Am I right? Something is very confusing here. I don't really understand. I'm going to have to double check this here because I'm missing something crucial. So when we start out, and let me just grab this here. Here's our row pointer, and here's our min x, min y, right? And what I don't super understand is I don't see where this is getting aligned to, where min x is getting aligned to 4. Oh, there it is. I see. There it is right there. So this expands min x out to 4, and this expands max x out to 4. Okay, good. I don't know why I was looked right past it. So this does the rounding to broaden the thing out so that we're properly looking at the right number of values. And when we look at those two, I guess the problem here, right, is that since this is post-expansion, it will always actually be greater than that. So, because remember, if we expand, once it's expanded, it will always occupy at least 1 row of pixels there, right, if it's going to draw anything at all. So what we actually need to do here is we need to make sure that if we ended up, so when I did the less for that was incorrect, it's really just if we end up with exactly 4 pixels to fill, so we're just doing 1 column, then they need to be ANDed together. And I think that's the only thing, right? That should have been the only thing anyway. And yet, does not appear to be so. Why not? Well, I want to step in. Been a long time since I wrote that code. What's going on here? Are we in? Well, we're in a debug build. Why do I not seem to have a compiled version of draw a rectangle? Oh, duh. That's in the platform layer. It doesn't get hot reloaded. There we go. Much nicer. We have to fix that jitter at some point. Drives me nuts. So that's much nicer. Now it draws the right size rectangle, so that's good. Everyone's happy. And I think that's good to go. And then the other one's a lot more subtle, but I don't think it's pretty easy to do. So if we go ahead and here, here's our draw rectangle quickly routine, which of course is not actually, it actually draws a textured rectangle, the inaptly name. The point that he was making about this one is a good point, and that's essentially that, hey, we've got this start and end clip masks here that we're doing some work, not much work, but we're doing some work to set up. But if you look at what happens with them, the right mask should always be taking care of them, right? And the reason why I thought I needed these clip masks in here was because, hey, we've got a clipping region that comes in from the outer code that we need to obey, right? But we always want that to be aligned anyway, right? We never want to be drawing something when we do our tiled rendering. We would never want those tiles not to be clipped properly to a 4-byte boundary, right? 4-byte boundary, a 4-pixel boundary, which is 16 bytes, because that's our write granularity, and so we kind of need that to be happening anyway. And so, in fact, we probably want them a cache line boundary aligned, right? We probably want them 64-byte aligned, so that the different tiles aren't sharing part of a cache line on the overlap as well. So there's a lot of stuff that we probably want to do there. So what that means is that we don't really need these start and end clip masks, because since we're never worried about since we know that our clip region will always be aligned to those 4x4s, right? Oh. No, but you know what? There is one reason why we still have to do it. Those start and end clip masks we do need, because otherwise they wouldn't work with stuff like this. This guy. Remember this clipping? That guy needs clipping to a rectangle in addition, which is not going to be pixel aligned. All right. So I think that's that. And hey, guess what? We are literally just in time for the Q&A. So I think we have successfully done all of our issues, and we can end the new year with nothing on the actual issue list except this one, which is done. I just have to actually recompile and switch to it. But that's good. Unfortunately, we still haven't done fix the room testing thing, but that wasn't on our issue list, so that's okay. I'm not gonna complain about that one. But I'll go to the Q&A here a little bit early, 2 minutes early, since there's nothing else to do. And Happy New Year, Canuckles. I guess are you in? Where are you in? You're not in Moscow, are you? I thought maybe you were. I can't remember. Jim says, in the compression code, there is an assert literal count equals 0. It seems to fire on some files. Should the literal buffer be flushed after the loop in case it didn't end on a run? So let's see. Well, so really there must be a bug in that case. I mean, you can see how it's meant to work anyway, and we wrote this code kind of fast and whatever, so I'm not gonna pretend that there's not lots of possibilities for nut stuff in here. But so what's supposed to happen is in equals in end is supposed to mean we got to the end of the buffer, and so at that point, right, at the end of the buffer, it's supposed to flush. It's supposed to go in here and flush, right? I guess the problem here is that in equals in end break will trigger first. So the problem, I think the whole problem is really just this probably has to happen here. Right? Yeah. Let's just check that a little bit. I think you can also do test now as well, right? And that succeeded, or thinks it succeeded anyway. All right. We should probably add that here. Hopefully that helps. Yeah. This Isaac, are you going to consider resizing the debug display for lower display resolutions, or would that not really be worthwhile since it's not part of the final game? Yeah, the latter, I would say. Again, stuff like that kind of depends in terms of like a real project where you're not dealing with constraints of like, hey, it's an educational stream and we have to make certain concessions to how we do things and stuff like that. Basically, what happens is you have to think about what your end goal is for the code. And so in some circumstances, I would say you should. In some circumstances, I would say you shouldn't. In the case of Handmade Hero, I think that would probably just be a waste of time, right? Because we've gone over how to do stuff like that, but it's not a mystery. Like, hopefully anyone who's followed the series can go do that if that's what they want to do. But in other circumstances, it might make sense to think of that as a more higher priority item. And the case where that's a more higher priority item is like, if you were trying to build like an engine or something that you were going to use on multiple projects, and there's a long lifetime for it, and things like that, then it makes sense to pay attention to human factors sorts of things when you're when you're just talking about debug code or utility code, right? So the way that I would think about that is just, how often do you envision this code being used? Try to spend the time proportional to how much you think will actually be happening there. So for example, let's say we're building a product like Unity or something like this, right? Where we're trying to ship like an engine that lots of people are going to use, then it makes a lot of sense to go, oh, hey, we should make sure like our debug code is aware of the screen size and has multiple things like this and all that sorts of stuff, right? And so I think that's like the way to think about it is just, is this part of the end product or not? And just saying part of the end product is like I said, it's kind of a little bit of a deeper question, because it doesn't just mean like, oh, if no player is ever going to see this, then don't do it. It could be that if lots of developers are going to use it, more than just the one who's sitting here and knows what machine they're working on. So if I was a team of like, on a team of 20 people, I might take more time, even if we're not shipping as an engine, I might take more time to worry about human factors stuff in there, because I know it's multiplied by 20, how many people are going to have to deal with this. Then it starts to make a little more sense, right? And so you always have to try, every exercise in programming is about trying to make sure that you're spending your time in ways that are going to be useful. On Handmade Hero, that tends to be an odd decision, because what's useful tends to be, is there something educational to be shown here? But in a project that has nothing to do with that, the project that's just about shipping a game or shipping an engine or shipping whatever, then the calculus is still the same, but the goal changes. And so then it becomes about, well, all right, I still want to be making the exact same kind of a mental trade-off model where I'm saying, where is the most useful place to spend my time? But the metric is, how much time will this save other people? How good will this make the end product for the people who eventually buy this thing? Is this something that's going to be used in the future? How much time will I save my future self on future projects? All of those things have to start to come into it then at that point, because now your metrics of what makes sense in terms of where to spend your time change. So on Handmade Hero, would I spend the time to do it? No, there's no reason for it. I'm not teaching anything useful at that point. Obviously, we don't need it because we're always on a 1920 by 1080 display. So it would just be a waste of time. But in another circumstance, it may very well not be a waste of time. And so it's important to distinguish between what's a waste of time to us is not a waste of time to somebody else. And all of that is just a part of being aware of the circumstance in which you're programming, who is being affected by it, and whether or not those decisions make sense in the greater context. A wee bit off topic, but have you ever considered setting up a green screen chroma key for your stream? No, I haven't. Again, just because I don't really care much about production values, because I feel like that's just a rat hole that you can go down. And the stream is just here to provide programming information for people who want it. And I intentionally never have gone out of my way to try and encourage people to come watch it. It's just here for people who want to come watch it. We don't advertise. We don't have higher production values. We don't really do anything other than just coding. And so, doing anything that fusses with trying to make the camera better or something like that is just time better spent making programming resources for the goals of this stream. What are your 2017 resolutions for Handmade Hero? None really. Like I said, just try to putting out useful coding stuff, right? MTS box, shouldn't the clip rect only be rescaled at the same point that the offset is done? Only the main buffer should have it. Well, no, I don't think so. Let me just double check. No. So if you take a look at what happens here, OpenGL bind frame buffer always uses the window width and the window height in all cases, right? So whenever it does bind frame buffer, it's going to set up that scaling transform. The only thing that changes between the two is the offset. So I believe the answer to that is no. The scaling always occurs. No high production value. Stream looks good, and there's a frame around the scare cam and a nice little fade-in timer. That seems like more effort than a lot of what I see. Well, yeah. I mean, that probably says more about the low production values elsewhere, but that the timer is actually just adapted from an MP3 player I wrote. And so I didn't write any of that code new. I just copied it, and we needed a timer to make sure that we stayed on schedule. So the only thing I added there was the bare minimum necessary, again, for the stream. And the reason that there's a window around me was because we found when we were doing the streams that I wouldn't know when I was programming that I was programming in the area where my head was, and people couldn't see it. So again, that was entirely based on necessity, not on production values. We weren't trying to make it look good. When I first started doing the stream, there wasn't one there, but we found that it was a problem. So again, anytime the thing is important for the educational purpose, I do it. But if it's not, I tend not to do it. Zoc2, so that black box is a window, not just an overlay in OBS. Yes, correct. So that is not an aspect of OBS. That's a thing that's actually on my actual screen, and it's there as a blocker to prevent me from basically it's there to make sure that anything you can't see, I can't see. So that I know, like when I come down here and I start typing on this line, I know that when I get to where my head is, I can see exactly where it is, and I won't do that, right? And yeah, I don't really know. I would, OBS is, I mean, it's free software or whatever. So, I'm glad it's there at all. But definitely I don't understand why streaming programs wouldn't have it built in that those things would be, sort of blocked out. So that the streamer knows that it's there. It seems like that would be a pretty basic feature that you would want. Jesse R. Meyer, please consider demonstrating a video's command list extension as a way of thinking about modern graphics dev. I guess what I would say is I feel like that's a little bit too far down the 3D rendering specificity rabbit hole at the moment. So I don't know that that's something that's really going to be within the scope of what we do on the stream. So I don't know that that's ever going to actually happen in the sort of Handmade hero. That's kind of like advanced 3D, because in order to talk about why you even want that or need that, you have to get to a certain point in terms of need that we're just not going to get to. So. Yeah. So, all right. Stretch. Let's close it down. All right, everybody. Thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you. As always, if you want to follow along at home, you can always pre-order the game on handmadehero.org. And it comes with a source code if you want to play around with it. We also have a forum site you can go to if you want to discuss what you saw in the video or anything about Handmade Hero. We have a Patreon page if you want to support the series. We have a schedule bot if you want to know when we're going to be live. And I fixed it over Christmas break. So the schedule bot, in theory, should be working. And it does appear to be working, at least I think. Yeah, looks pretty good to me. I think that's right. 12 hours ago, 4 hours ago, in 1 hour, join us. So 1 hour, 3 hours, that's correct, I guess, roughly. Yeah, and it was 7-11. So good news, the tweetbot, I believe, has been restored to proper functioning. I wish this said, I kind of want to check this. When did it say it? Yeah, 9 so 10 a.m. The stream was supposed to start at 11 a.m., so that's about the right time. That's all good. Thank you. Great. Amazon deal. Yeah, fantastic. So anyway, that's all set up there as well. And we also, of course, have an episode guide. If you want to catch up with old episodes of the series, you can go check that out as well. That's about it for today. And we will be off tomorrow on account of the fact that it's New Year's Day, so probably most people won't even be up. In time to watch the stream, but we'll be back to our regular schedule of Saturdays and Sundays in January, where we're going to do some upgrades to the renderer to do with 3D, and then we're going to start on the gameplay code. So we've got two sort of fun things coming down the pipe, yeah, I guess 2017 will be the year of gameplay coding in Handmade Hero, which of course is not really something that I'm super looking forward to because, to be completely honest, I don't really like gameplay coding. That's why I'm an engine programmer, not a gameplay programmer. But what are you going to do? Programming, unfortunately, is oftentimes about programming things you don't want to program as well as things you do want to program, because not everything is going to be something you want to program. And if you want to be able to do complete projects by yourself, you're going to have to do that. Maybe you can always get on a team where someone else does it for you. But usually you're not going to be that lucky. You're usually going to have to do some programming things that are not your favorite. All right, so anyway, that's it for today. Thank you, everyone, for joining me. Let me just close this stuff down here. There we go. And I will see you all next week. Take it easy, everybody.